For our next video, we are going to go over some of the project settings within SDS2. This will go over both Job and Fabricator settings and really how to navigate the settings. Settings are going to be very important to go through at the beginning of the project, as this is the most important part of starting a new project, as it will affect the outcome of the entire project. We are going to start with our job settings. From our home screen, we're going to go ahead and select Project Settings. As we can see in here, we do have Fabricator and Job, but we're going to start in our Design section of our job settings. So if we select Design, we can see Design Settings, we see Plate Design Settings, Moment Plate Design Settings, Flange Plate Clearances, Weld Design Settings, Seismic Weld Access Holes, Schedule of minimums for structural members, schedule of minimums for single plate shear connections, field clearances, and composite reaction factors. Let's start by looking at the design settings. Go and select that. And we can see inside of here, we can change our connection design method. We can specify here within our design method whether we want our different connection design to follow the AISC if we are using the ASD or LRFD. We have some different options. Do we want to show our imperial moment loads in kip inches or kip feet? Inside of our beam design loads, this allows us to specify how our default loads are calculated, whether we want that on a certain percentage of the uniform allowable load or the maximum web shear out of the manual. Or if we check on that minimum setup connection, that is automatically going to lower the loads until it can pass whatever we have in our setup for our minimum connection information. We can specify the percentage of the maximum allowable moment. Do we want to design it as a seismic connection? Do we want to calculate the tie-in loads? And then for our seismic moment type, do we want to use OMF, IMF, or SMF? What is our default material connection steel grades? If we're using composite design, what is our composite loads and the strength and thickness of the concrete? And then for our bracing, what is our percent of allowable tension and compression loads for our horizontal, vertical, and then intersection horizontal braces, as well as our intersection vertical braces. We have the option to pass those gusset beam interface forces to the beam, so we can pass some of the loads from the vertical braces into those beam connections. And if that is checked, what is our UFM special case design? We can specify our connection information for our wide flange vertical brace to gusset web or flange. Are we using seismic vertical brace gusset design, and with that SCBF or OCBF? And then do we want to use the AISC seismic design first edition gusset geometry? And then our minimum bolt rows for our horizontal and vertical braces. At this point, I'm going to say OK or cancel because we did not make any changes. Our plate design settings, we can specify the distance if we want to design a shared gusset or not. And then we have the option to design for a beam and column gusset if the flange ends are closer or less than. What is our multiplication factor? Do we want to design by first incrementing the plate thickness or the plate size? Do we want to round our flat plate values? Do we want to always provide transverse beam stiffeners? What is our minimum beam stiffener plate thickness? What is our total stiffener clearance? Now, if we take a look here, we can see our total stiffener clearance of 1/8 is going to be a 1/16 at the top and a 1/16 at the bottom. And then do we want to use the HSS column reinforcing plates? If that is checked, if the system requires that reinforcement plate, it will design that with the plate. If this is unchecked and the system sees that that is needed, it is just going to result in a failed connection. Next, we have our moment plate design settings. So in here is where we can go in and really specify our setup for our moment plates. For our stiffeners, do we want those coped or clipped? Do we want our corner operation for our flange stiffener size by? What is our minimum plate thickness for the doublers, the extensions? What side of the column web is that doubler on? For our flange stiffeners, do we want those designed as needed? When needed, use full depth, or always use full depth at all connections. And then the same for designing the plate thickness by. When framing to the column web, do we want to determine the welded moment flange stiffener thickness by a dimension or a percentage? We have the option to extend the plate. And then do we want those top flanges flush top or flush bottom for the top flange and the bottom flange? And then if we want backup bars on our welded connections, we can specify what type and grade we want to use and what the sizes are below. Next we have flange plate clearances. When we have a moment connection, what do we want our flange plate clearances at? What size of gap? Right now everything is set to be a 1/4 inch, but based off of this table, you have a nominal depth, so anything less than an 18-inch deep beam is going to use that gap. Between 18 and 21, we'll use the 1/4, which everything's 1/4, like I said. And then the bottom one is anything larger than a 30-inch beam. You have the option to specify where you want that gap, whether it's at the top, bottom, or both. And then when you are using a wide flange brace, what is your horizontal brace gusset gap, as well as your vertical brace paddle plate gap, and then your maximum gap for a single filler plate. Next, we have our weld design settings. So this is where we can go in to specify all of our basic weld information, as well as our welded moment information. So we have our weld standards, the tensile strength and the electrode type. Do we want to perform chamfers? Do we want to show the weld length on the symbols? And then for our moment connections, what is our weld gap, the reentrant cut radius, root face dimension, web setback dimension, groove angle, then the alternate one, reentrant cut radius length, depth, and then our flange flush length. And then what reentrant cut type are we using? For our cut type, is that parallel to flange or perpendicular to the web angle? And then for our weld size, what is our minimum for the job? Our maximum weld size for non-strength connections, so for like our column base plates is an example. And then our maximum field weld for our HSS braces. And then our weld pattern for our base plates, cap plates. So we want that as 2 faces, all around, all faces, or all faces with a seal. And if we're using a seal weld, what is that seal weld size? The next thing we're going to take a look at is our seismic weld access holes. If we take a look, this is going to be number 1, this is number 2, this value is number 3, this value is number 4, and this value is number 5. And then we can specify our web setback based on the hole type, our weld gap, and the root face dimension. Now you can specify what access hole type is being used in your shapes file. We're going to skip over our schedule of minimums for our structural members and our single plate shear connections, as we will cover those in a later video. And we'll look at our field clearances. So for our non-auto standard connections, we can specify our field clearances for our shear plates, T's, our clip angles on supporting or supported, our bent plates, end plates, seats, splices, or plain end. For our brace connections, when it's braced to another member or braced to a gusset. For our joist connections, when it's a plain end and bearing, whether it's a seated connection, bottom chord extension, or knife plate. For a welded connection, we can specify when it's a brace to a supporting member or a brace to brace. For our end plate field clearances, do we want to round that end plate field clearance or not? And then our steel to concrete connections. What is our end and pocket clearance, as well as our pocket grout thickness? So again, these are going to apply for non-auto standard connections. When we get into our connections, we'll explain how to set these field clearances for our auto standard connections. And then we have our composite reaction factors. So based on our nominal depth of the members, what is our Rx factor? This allows you to set basically a percentage or a factor of what that composite design is going to be designed by. The next thing we're going to take a look at is our bolts, washers, and holes. To go back to our job settings, we can simply just click on Job. We can then select bolts, washers, and holes. Inside of our bolts, washers, and holes, we're going to start by selecting our bolt settings. In here, we can specify for our AISC 13th edition bolt design, do we want to limit the state for our slip critical bolt design? Do we want that design as stated in J 3.8? Design all bolts with slip as a serviceability limit state, or design all bolts to prevent slip at the required strength level. Again, that does only apply to the 13th edition. For our default bolt class, do we want to make all bolts automatic, all of them be field bolts, or all of them be shop bolts? With that set to automatic, the system will go through and decide which should be field bolts and which should be shop bolts based off our project settings as well as the framing situations. What is our minimum bolt length? What is our minimum stick through? What is our maximum stick through? Do we want all imperial bolt lengths to be in 1/2 inch increments? For metric bolt lengths in 10 millimeter increments? Do we want to add washers to prevent shank out when needed? What is our maximum bolt gaps for our field bolt and our shop bolt? And then we can specify our available bolt diameters. We can use both imperial and metric within a project if we wanted. And then these are the bolt sizes that we want to specify to be allowed in this project. What is our hole allowances? Do we want that based on job units or bolt units? And then do we want hole diameters to match the primary units? So if we were using both imperial and metric for this project, for example, because we are using imperial units, if I used a metric bolt, the hole diameters, if this is checked, the hole diameters match primary units, would automatically convert that to imperial. If that is unchecked like it is now, then it would show on our detail in metric. Below we have our default bolt criteria. What is our default for our non-moment bolts, so our bolt diameter? And if I change this, I have the option to apply this to our auto standard connections. And then the same for the bolt type. What is our default type? And if I want to apply that to all auto standard connections or not. The default bolt size that is called out here is going to affect how our details are shown. Our non-standard hole sizes, so anything that is not a 13/16 hole because of the oversize here, will be called out. So if we wanted to see every single hole size, we could come in here and put like our default at 1/4 inch or something similar, and then when we detail our members, all of those hole sizes should be called out. We can specify our moment bolts, our vertical brace gusset to supported, or horizontal brace, the K-joist, KCS joist, LH joist, DLH, SLH joist, and our G-joist bolts, as well as our BG, VG, and CJ joists. Then we have our flush frame joist connections and our HSS welded brace erector bolts. So again, for any of those, we can specify the bolt diameter and the bolt type. Next, we have our bolt specifications. As you can see, this is for our 15th edition. If we're using a different edition or a different manual, this will result in different bolt types. But we have our bolt type, the material, the group, our connection method, the surface class, our shear F and V, our tension F and T, and then our nut grade values. If I wanted to, I could come in here and specify whatever type of bolt I wanted and give it any name. As long as I have all of these fields filled out, that will then be a usable bolt in the model. However, the values for our shear and our tension are going to affect how our calculations come out. So we will want to make sure that those values are correct. Next, we have our nut and washer schedule. We can specify our grade name and nut type. Our nut types, we have our heavy hex, heavy square, and jam nuts. And then in our washers, we can specify our grade name and the washer type. As you can see, we can specify a hardened washer, a flat washer, a bevel washer, a direct tension indicator or DTI, a square plate, a round plate, a hillside, or material plate washer. Next, we have our washer settings. This is where we can define the default washers to use for each hole type in the different configurations. So based on a flat washer, a hardened washer, that's going to be our default thicknesses. We can then go in and specify by bolt type when we want to use what type of washer. So for standard holes, we can specify a primary or secondary under the head and under the nut. So we can specify based on the hole type what washer we want and how many. We then do have the checkbox for use tension control bolts. This is going to allow you to set your TC bolts for your job for both shop bolts and field bolts. If we take a look at our F18, 52N, SC, and X, we can see those are checked on by default, and no matter what we do, we cannot uncheck those. Same for the F2280 bolts. Next, we have our user slot lengths. When I come in here, this is going to allow the user to define a slot length based on the bolt diameters. So you have the option for a slot length number 1 and your slot length number 2. The default long slot and short slot values will not be affected by this. This is a completely separate user-controlled slot length. I'll go back to my job settings, and we'll take a look at our material grades. Inside of our material grades, this is where we can set up all of our default grade information for our different material types. So if I go into angles, we can see our grades are in here. And just like I said with the bolts earlier, the FY, FU, RY, and RT values are going to define how those calculations are generated. We do need to make sure those values are filled out and are accurate. The first line in here where it says default 1 will be the default grade used when adding those material types and will affect any material that is already added in the model. So you could always come in here, select whatever steel grade, and move up or move down to make those adjustments. So we have the option to control our angles, our cruciform materials, our channels, flat bars, grading, HSS/TS production standards, our HSS/TS grades, our pipe grades, plate grades, rebar grades, round and square bar, shear and threaded stud, our turnbuckle, clevis, and pin, our wide flange, and our WT. Next, we have modeling. And this is going to allow us to set up some general modeling settings. For example, our colors, our descriptions, our revisions, and some offsets. We can go in and set our job north. We can set up our zone and sequences. So for this, we are going to want to set up some zone and sequences. So go ahead and select that. And then for this project, we are going to have 4 sequences. So we need to change our maximum number of sequences from 1 to 4. And as soon as I select tab on the keyboard, we can then see our sequences updates to 4. And then once you have those 4 shown, we're going to hit sequence names. And for this project, we want to call this 1A, 2A, 3A, and 4A. Once I have that set, I can say OK. And with this, we can specify what zone houses which sequence. In this case, we're only going to use sequences since it is a smaller model. But if we were using a very large model that we would want to set up and send out differently, we could definitely do so. Once I have these 4 set up, I'm just going to go ahead and say OK. Next thing we're going to take a look at is I'm going to go to Job, and then we could come in and set up our custom properties. In this case, because it's our basic training, we won't have time to get into custom properties, but this is where we could go to set up custom properties for job, members, material, bolts, holes, and welds, and then activate any that are in there by default. And then we have our concrete and rebar, which we won't get into for this as well, but we can specify our concrete and rebar information. Next, we have our fabricator setup. Standard fabricator connections is going to allow us to set up defaults for the connections, and we are going to take a look at this later on. Next, we have our piece marking, where we can specify our standard marks for our all bolted clip angles, our bolted welded clip angles, and all welded clip angles. We'll cover that a little bit later. Then we have our standard piece marks for our shear plates and our end plates. So we could come in here and specify our piece marks, the thickness, and then generate all the information to calculate our width and our length. Again, we'll take a look at these a little bit later. Then we have our member and material piece marking options. If I open this, we can specify our main member information. Do we want to break major marks apart by? We have an option to not break those, to break those apart by field bolts, by our sequence, by zone, or individual member. So if you have two members that are exactly identical in different sequences, and you have it set to break by sequence, those would then get different piece marks. If you have this set to individual member, no matter what, no members in the model will have the same piece marks. So you would have a lot more cleanup work, but then you would have very accurate tracking on that. You have an option to use the member mark for the member main material in the shop bill. This checkbox here will only call out the member mark for that main material in the bill of material, not in the model. So your bill of material would then differ from what the model shows. If that is checked, you have the option to show submaterial mark for beams, columns, vertical braces, horizontal braces, and miscellaneous members. You then have an option to use the member mark for member main material in the shop bill for stair member details. You have the option to show the submaterial mark for main member on stair details. You have an option to use the member mark for member main material and model. So this is very similar to that first checkbox. However, this is going to apply in the model. Well, remember, everything that is in the model carries over into your drawings, so that way your marks would match both in the model and in your bill of material. You have an option to show linear measure for handrail and shop bills, and if that is checked, you can show the linear measure for your rails, for your posts, your elbows, and your grab bars. Then you have the option to show submaterial marks for posts on handrails and the mark for the rails on handrail members. Next, in our submaterial tab, we can specify our designation for our primary submaterial mark, our secondary submaterial mark. So for both of those, we have the option for a piece mark, or the material type and piece mark, or the material type, size, and piece mark, as shown here. What is our starting number for our material piece marks? So as we add materials into the model, we get different mark numbers. We get an A1, A2, A3, A4 if we added 4 angles in a row for our first 4 materials. But then once we change to wide flange, and that's just going to continue growing. So like if we added some wide flange materials, then it'd go W5, W6, W7, W8. So what is that starting number we want this to start at? Now, this is not an option that it's used a whole lot unless you are planning on merging your projects. If you're merging your projects so you don't have conflicting piece marks, you can go in and start this at a very large number, so that way you know you will not conflict with the other project. What is your default designation for user added material callouts? Do we want quantity included in the user added bolt callouts? and the designation for a user added bolt callout. We have the option for bolt type or bolt size and type. Do we want to show the submaterial quantity on submaterial details? Do we want to show the member marks and the quantities on those members on the submaterial details? Do I want the prefix, the imperial material callouts that are less than 12 inches with a 0 dash? If that is unchecked, it would just show by 10 instead of 0-10 for something that was 10 inches. We have the option to break submaterial marks apart by sequence. And if that is broke apart by sequence, do you have an option to include the sequence in the submaterial mark? Same options for zones. You have the option to indicate the near side and or the far side of a submaterial in the main view on details. So you have the option for a near side callout, the far side callout, or both near side and far side. You can show non-standard grade notations with the piece mark on member details. If that is checked and you have a plate that is not your standard grade, it would show that in the callout. You can show piece marks for submaterial bolts on member details. You can reuse piece marks. If that box is checked, anytime you close out of the model, any mark that was in there at one point but is no longer in there would then be able to be reused. For example, let's say I have an angle 4x4 by quarter that is 10 inches long with no holes. Well, that is going to be given a mark A1. Let's say I delete that out of my model and close. Well, then I reopen it next. A1 could be something completely different. That could be a 5x5 by 3/8. It could be, anything different than what the 4x4 by quarter was. If that is unchecked, then that is just stored in a list in the background. Next, we have an option to force flat bar description to use the smaller of length and width. And then we have the same for our bent plate description. We can force that to use the smaller of the length and width first. Then we have the option to show piece marks in all views on member details. So we could see, in this example here, we can see P77 is called out in both the main view and the base plate view. We can see the BP1 is called out. Where on the right, we only see the base plate called out in that base plate view. And we don't see P77 because that's going to be shown in a different view. Next, in our group area, we have the option for submember piece marking options to combine all like submembers contained within all group members. Combine all like submembers by same grouped member piece mark. We have the option to use member mark for member main material in the shop bill of group member details. We have the option to use the group mark for main submembers main material mark in the model. This will make more sense once we get into using the group members. Next, we have our prefixes. For our different material types, we can specify what the prefix for that material is called out at. We have the option to then specify the plates. Next, we have our member descriptions. Based on the default descriptions for our beams, columns, horizontal braces, our vertical braces, our girt, purlins, stairs, and group members, we can call out whatever we want those to display at on the member details as well as in the bill of material. And then we have our piece mark prefixes. Inside of here, we can specify how it's going to call out our piece marks in the model, and then when we go to do our detail sheet auto loading, what designation do we want to use for our different members? We'll go back to our fabricator options and we'll take a look at our sheets and reports. So here we can specify our default bill of material layout. We can take a look at our default sheet revisions, how we want that all to be called out, and then our sheet loading criteria or settings, which we'll get into at a later time. Next, we have our detailing. And in our detailing, we have quite a few different options. Let's start by looking at our dimension settings. In my dimension settings, we can see we have a general, beam, column, brace, and miscellaneous tabs. In the general, we can start by specifying our dimension terminals. Do we want those as arrows or slashes? Our submaterial sloping hole layout dimensions. Do we want that on work line, furthest hole, nearest hole, or none? For our main material sloping hole extension dimensions, we can specify if we want that to the top left hole, bottom left, bottom right, or top right, or we can click on each of those, and if we wanted we could have all 4 of those enabled, but I'll leave mine the default 2 outside ones. We have the option to show the point-to-point dimension on the main dimension. We can show the material grade on the main dimension. We can show the on radius dimension for arc dimensions. Do we want to show the angle dimension for arc dimensions? Do we want to break dimension lines at label interference? Break material lines at label interference? Break bevel lines at label interference? Do we want to combine dimensions across the detail? Do we want to use extension dimensions on some material details? And then do we want to use extension dimension tails on the submaterial details? What is our material point dimension holdback distance? Do we want to lock the outline layer? And then do we want to lock the manual editing of dimension text? Do we want to display the measurement unit on angle dimensions as degrees or radians? And then what is our dimensional precision? Next we'll go to our beam tab. And we have the option to show extension dimensions, to show those extension dimension tails, to show the origin for those extension dimensions. We can dimension the reference point on a symmetrical web holes and flange holes. We have the option to show chain dimensions between hole groups. We can show extension dimensions from the left end of that member or the right end. Do we want the extension dimensions on bolted connections from the end of the beam or from the face of the connection? For welded connections, do we want that from the end of the beam or the face of the connection? And then for coped dimensions, do we want that from the end of beam or from the face of connection? Then we have the option to show the end of beam to the face of clip angle dimension. Next we have our column. And here we can specify if we want to show extension dimensions and if we want to show those tails, and then the origin. Do we want to dimension reference point on the symmetrical web holes and flange holes? Do we want to show the chain dimensions between hole groups? And then our extension dimensions, do we want those pulled from the top or the bottom? And then our extension dimensions, do we want those pulled from the top of the plate or the bottom of the plate? And then our overall dimensions, from the cap plate, do we want that from the top of the plate or the bottom of the plate? And then from the base plate, do we want that from the top of the plate or the bottom of the plate? So we could have that called out basically on the main material only or from the outside of both plates. And the same for our extension dimensions. Next, for our brace, we have some options for our horizontal braces and vertical braces, and they're actually going to be the exact same. We have the option to show extension dimensions, show extension dimension tails, to show the extension dimension origin, dimension the reference point on symmetrical web holes and flange holes, and then we can show chain dimension between hole groups, and then do we want to show the extension dimensions from the left end or the right end? And then for our miscellaneous. On miscellaneous members, do we want to show extension dimension tails? For rolled plates, do we want the width taken from the inside, outside, or center? For our bent plate lengths, do we want those calculated at the center line, or do we want to use a custom K-factor? For using a custom K-factor, this is what we are going to use to determine that. So in this table, we can see for plates between 0 and 1/2 inch, anything greater than 1/2 inch to less than or equal to 1 inch, and then anything greater than 1 inch to 1.5 inches, and then 1.5 inches and above. and then the specified K factor for each of those. When using the unfolded surface template bend lines, do we want to show the beginning and the end bend lines? For our beginning bend line, what color and line type? For our center bend line, what color and type? And for our ending bend line, what color and type? Next, we have our drawing presentation. And in here, we can specify our sizes. So for our labels, our section sizes, our piece marks, and then the weld symbols, we can specify the character height and the width height ratio. And then for our dimensional terminals, our pointer arrowheads, and our work point symbols, what size do we want? Next, we have our default fonts and the font styles for our labels, dimensions, symbols, member labels, member piece marks, member section sizes, the bill of material, and the sheet revision. And then we have our pens. What are our default pen colors for our bill label, our detailing label, the pointer, section size, piece mark, member pen, cloud pen, weld pen, dimension pen, bevel pen, grid line and bubble, and then our filled hole, our hatch pen, and our member detail pen color. The pen color that is set here is going to determine the thickness of our pen. If we take a look, I just pulled up our line weights, and we can see pen 1 correlates with the white, or the pen 1, and the red is pen 2, yellow is pen 3, green is pen 4, cyan is pen 5, blue is pen 6, and magenta is pen 7. And we can specify our thickness of that pen and the color of the pen when it plots. Next, we have our bill of material. We can specify the spaces between fields in the bill of material. What is the bill item's character height and the width height ratio? Do we want to show the grid? Do we want to wrap fields to the next line if they extend beyond that? Do we want to extend the foot-inch separator? What is the bill of material rotation? Outside pen color, inside pen color. What is our max space between items? Our minimum number of rows and our maximum number of rows. Our title text, the width height ratio of the title text, the title and header fonts and styles. Next, for our revision chart, we can specify if we want to show the grid, wrap the fields to next line. What is our number of lines on that revision chart? The header position, do we want that at top or bottom? And then the revision line, do we want that to go from top to bottom or bottom to top? What is our rotation? The anchor location, our character height, the width height ratio, the font style, and then our outside and inside pen colors. Then for our tables, we can specify our outside and inside pen colors, the rotations, the anchor location, do we want to show the grid? And then for our header and our body, we can specify the font style, the justification, the character height, the width height ratio, and the pen color. And then our primary dimensions. This is going to be set based off of what we selected for our units when we were creating our project. If we want to, we can change our units here, and this will affect how they are shown in our model. We can specify imperial, feet-inch fractions, inches sixteenths, inches fraction, inches decimal, or metric. We can lock those units, so that way it only displays those units. We could still type in, 10 millimeter, and it would apply that dimension, but it would show it in imperial. What is our character height? The width height ratio. We have the option to expand dimensions that are less than or equal to 5/16, as shown here. What is our dimensional precision? And then our label pen color. We can then go show our secondary dimensions. If we check on the option here to show secondary dimensions, we can actually show either imperial inches sixteenths, inches fractions, inches decimal, or millimeters on that same dimension line. It would just be placed on the lower half. And then we have our colors. So our default layer colors, we can specify for our user adjusted, our detail rule annotations, Our reference dimension, user annotations, system annotation, outline, new comment layer, and new layer. Next we have our line weights, which we already went through. We have our general presentation, so we have our default member and submaterial detail scales. We can specify a scale based on the nominal size of the member. What is our standard edge distance for our rolled sections or our plate materials? And then we have the checkbox to show non-standard edge distances. So if our edge distance that we have set does not match what is set here, then it will call out that dimension automatically. We have an option to clear the detailing flag when detailing current piece mark. We can prompt, and then do we want to prompt default set to yes or no? What is our shop bill of material weight precision? Do we want to always round the unit weights up? For our weights, do we want those to always add up, or do we want the actual total weights? For our shop bill, do we want that weight based on the volume or dimensions? The dimension will include any cuts or holes that are in there. It will not subtract those weights out, where volume will include any cut or any hole that is shown and will remove those weights. Next we have the option to show cross hatching, show cut surface hatching. We can show face A and C holes shown on face C and A. Same for B and D and D and B. We can show the main member size. We can show the K distance with that main member size. We can show submaterial layout dimensions on member details. We can show shop bolted slotted holes, and then what that minimum slot length is that we want to see. We can use curved pointers. We can use pointer face indicators. And then for a single quantity designation in the main callout on details, do we want that spelled out as 1 or just the number 1? In our bolt detail settings, we have the options for our bolt designations shown on reports or details as bolt material only or bolt material and type. Do we want our field bolts listed on supporting or supported? Do we want to plot the field bolt bill of material information? Do we want to summarize field bolts listed in the bill of material? And do we want to include the quantities and weights for that? Do we want to summarize like field bolts on details? Do we want to list washers and secondary nut with the field bolts on details? Do we want to summarize like shop bolts on details? Do we want to list the washers and secondary nut with the shop bolts on details? Our bolt summary format on details. Do we want the unit quantity, total quantity, or both unit and total? For our bolt callout, do we want to include the units of measure? And then do we want that no symbol? Do we want the DIA typed out, or do we want the diameter symbol? Same options for our nut callout, and the same options for our washer callout. And then we have the checkbox there if we want a bolt, nut, and washer to be broken out in the bill of material. Next we have our connection erectability settings. When we're using a stability angle, what is the default section size? Do we want to show the field bolted stability angles on the column, or our shipped loose, or on the beam? What is our maximum allowable K infringement? This is an option that the system will automatically compare this value to what value is in the book, and will use whatever the smaller of the two is for the allowable K infringement. Do we want to use backing bars for pre-qualified welds? Do we want to do weld prep on a moment flange plate? For our safety erection seat, what is our default section size? Is that bolted or welded to the supporting member? Do we want to attach the long leg to the supported or supporting member? What is our gauge on leg to the supported member as well as the supporting member? And then what is our gap for the safety seat on the bottom flange? And then we have our bolt detailing options. Based on our bolt size here, we can specify our default spacing And if we are using TC bolts, what tool type are we going to use? The large or the small? And then we can specify our different tooling information based on the gun we are going to use. So we can specify our H1, H2, our C1 diameter, large and small, and then our C2 value and our C3 value. Next, we have our member detailing settings. So for our beams, do we want our preferred bottom flange view style as a cross section or worm's eye view? Do we want to provide the minimum cope depth? What is our minimum clearance for the cope? What is our minimum cope radius center clearance? Do we want to round the cope length to the nearest quarter inch? We have an option to round the cope depth to the nearest. We can specify a cope radius. We can specify our cope cut type, whether it's perpendicular to the web or parallel to the flange. We can round off material length where possible. What is our member end edge distance? Do we want to square cut the ends of sloped beams or spliced beams? Do we want these to be detailed in position? So if this is sloping, the detail would slope. Or do we want those horizontal? Do we want to show the design loads on details? Either none, input, or all. And if that is input or all, we can show the member quantities and the member numbers with that. And then we can show the capacity load on the detail, either none or all. And the same options apply for show member quantities and member numbers. Do we want to see the grid notes on the details, either one or all? Do we want to show the end elevations on the details, none, first, or all? And then our end elevation reference point. Do we want that referenced back to the material end or the work point? And then do we want to add work point dimensions? And then do we want to show camber on the bill of material? Next we have our columns, which are going to be our preferred base plate view orientation, whether it's bird's eye view or worm's eye. Do we want to show face A and C as required, always, or never? We have the option to annotate faces of pipe on detail. Do we want to mill cut the column ends? Do we want to show erection pinholes? If that is checked, we then have the option to have those be CNC downloadable, and then we can specify our hole diameter and the vertical edge distance of that hole. Do we want our columns detailed in position, vertically or horizontally? We can show the design loads and capacity loads. Do we want to see the grid notes on the detail, none, one, or all? Do we want to show the end elevations, none, first? And then that top elevation, do we want that from the material end or the work point? And then do we want to show the sections that are framing into the column? And then when we're using a shear through plate, what is our default notch radius? And then our total notch width clearance. Then we have our vertical braces, where we can locate the angle braces on the neutral axis. What is our minimum member end edge distance? Our gusset to supporting member, is at welded or a clip angle? Is this detailed in position or horizontally? Do we want to show the design and capacity loads? And then the grid notes. Do we want to show the end elevation at the work points on details? For our HSS braces, do we want that HSS erection bolt is none, one, or two? Our hole type for those HSS erection bolts, we have standard round, short slot, oversized, long slot, or user slot 1 or 2. Our intersection gusset notch preparation. Do we want that to be a rounded slot or weld all around? Our default HSS notch radius. What is our total notch width clearance? Our HSS double paddle plate clearance. Do we want a welded angle end weld, or do we want the welded angle balanced welds? And then what is our maximum web stiffener thickness? Our clip angle connection of the gusset to the supporting member. That gusset to clip connection, do we want that welded or bolted? What is our default clip angle size? Do we want the long leg attached to the supported or supporting? What is our hole type to the supported and supporting? What is our gauge on supporting and a gauge on supported members? With those both set to 0, it'll just use whatever is in that shapes file. Do we want to stagger bolts in the clips? Do we want to use expanded bolt spacing? And then do we want to allow for reduced edge distance for 7/8 and 1-inch bolts? For the horizontal braces is going to be very similar. We can locate on the neutral axis. What is our minimum member end edge distance? Our gusset to single beam connection, whether it's welded or clip angle. Detailed end position or horizontally. We can show the design loads and the capacity loads. We can show the grid notes. For our back-to-back angles, what is our stitch plate gap? Do we want to allow material work line offset? For our HSS erection bolts, do we want none, 1, or 2? Our hole type for HSS erection bolts. The paddle plate clearance. Do we want welded angle end welds or welded angle balance welds? And then our maximum web stiffener thickness. For our clip angle connection of gusset to the supporting members, our gusset to clip is that welded or bolted. Our beam to clip is that welded or bolted. Our attached clip to, we have either gusset or supporting. We can attach a gusset to either the brace or supporting. For our gusset clips, we can either specify both sides, near side, or far side. What is our clip angle section size? Do we want to attach the long leg to the supported or supporting? Then we can specify our hole type to the supported and supporting. What is our double gauge on the supporting member? Our single gauge on the supporting member? And then our gauge, do we want that measured from the gusset center line or the gauge on leg? What is our gauge on supported member? Do we want these bolts staggered? Do we want to allow reduced edge distance for 7/8 and 1-inch bolts? And then our clip to gusset dimension. For our handrail, do we want that noted at the top rail from not noted, the top of top rail, or the center of top rail? And then do we want noted at the bottom of post? For our stairs, do we want the preferred stringer auxiliary view orientation from the outside or the inside? And then our new stair stringer length on the bill of material detail. Do we want that pre-cut or post-cut? For our stitch plates, what type of spacer for our double bracing? We have an option for bolted rings, bolted plates, or welded plates. What type of spacer do we want for welded connections? What is our maximum allowed stitch plate spacing? What is our minimum number of allowed stitch plates? What is our stitch plate extension beyond the brace? And the stitch plate width. Being that those are auto, connection design will automatically go through and design those. Next we have miscellaneous. Do we want our miscellaneous members detailed in position, horizontally or vertically? And then do we want to add the bearing bar thickness to the description in the bill of material for our grading material or grading tread material? And then our tension only braces or our rod braces. What is the length of the bottom rod for rod bracing? What is the length of the rod brace threading? So how long are those threads? What is the gap between rod braces at the turnbuckle? And then pin type, is that headed or a cotter pin? Next we have our member view defaults. We can specify based on the member type. We can specify for each of these views that comes in, if we want to specify how far in and out we are looking. If this is auto, SDS2 will automatically design those as it needs to. Same for our material views. You can specify based on each material type how those different views are going to be seen, how far in and out, or you can leave that auto and let SDS2 decide that as it needs to. Next we have our detailing defaults. With our detailing defaults, we can specify for our members, group members, and submaterials how those are going to be detailed. We can preserve existing drawing annotations. We can detail using templates, remove the snap lines, our verbose progress updates or show applied templates. We can dimension user created materials, dimension the holes on those user-created materials, show non-annotated system views, preserve system set detailing flags, preserve user-modified bill of material, detail with revisions, or shorten. We have the similar options for our group member and our sub-material. We can specify our non-standard field bolts, how we want those called out on erection views. We can specify our detail erection view defaults, which we will look at later. Then we have our detailing symbol settings. Our bevel symbols, do we want those based on a certain dimension, 12 or 10 depending on your units? Do we want to show the bevel angle degrees with the bevel symbol? Do we want to combine weld symbols? Do we want to allow weld symbols to be drawn on material? Do we want to use pre-qualified weld tail text by default? Do we want to add weld leader cranks always or as needed? Do we want to allow hole symbol to be drawn on the material? Do we want to allow the piece mark to be drawn on material? Do we want to show the paint stripe on the framing side of the shear plates? Do we want to show non-standard hole sizes on the drawings? Do we want to show non-quad boundary slot rotations with a symbol note on detail drawings? Do we want to call out standard holes with mixed bolt/hole units on the detail? For our non-standard holes, do we want those clouded or do we want a pointer? And then do we want to cloud and note any holes that are having a slip critical bolts on member details? So if there is a slip critical hole or bolt being framed into a certain connection, it will automatically cloud that and place whatever note we have set here. So we have up to 3 lines of text we can input there. Next we have our galvanizing settings. We can specify our galvanizing options for the general, so like our kettle defaults. Do we want to break apart galvanized members? What is our default surface finish? What is our default vent and drain hole diameter? What is our default vent and drain hole plug type? Do we want to add galvanized duplex coating label to the remarks column in the bill? Do we want to add no chromate quench note to the detail for members with duplex coating? And do I want to cloud and note vent holes on member details? We have our erection view member labels, which we will look at later. Our CNC center marks. Do we want to show those center marks by default? And then our position and match marking. Do we want to include position marking, where it would go through and add in pop marks for our different framing situations here? But in this case, we're just going to cancel out of that. I'm going to go back to Fabricator. And then our concrete and rebar, we can specify some of the detailing options there when we are using concrete and rebar, if that is present. Our crane limits and appearance allows us to specify how cranes are shown. Our stair treads is where you would set up your default tread types. We will visit this later. We can specify any categories that we would need to, which we won't get into for this training. Our user routing settings allows us to set up default routings that can be applied later, but again, this is not something we'll get into. And then our project output. This is going to allow us to specify the default output area for reports, drawing conversion, CNC, BIF, estimating, design link, model link, and parametric. And then we can print our Fabricator settings out.